So let's continue talking about our distance formula, which allows us to find the distance between any two coordinate points. So remember that formula that we derived in the last video? The distance between the 2 points, we call that d, is equal to the square root of the difference between the two x values, which we will label as x2 and x1, plus the difference between the two y values, which we call y2 and y1, and we're going to square that as well. And remember, this is coming from the general idea that we have 2 points, x1, y1, and x2, y2, where these can be any possible values on the coordinate plane. And keep in mind that with these points, it's important to label the x1 with y1. So you don't want to have x1 and y2 or x2 and y1. You want the subscript to be the same within the coordinate point. So using this formula is essentially just matching up x1, y1, x2, and y2 to these two different points here. So let's rewrite the points below this. And it doesn't matter which one we label as which, just as long as we're consistent. So let's say that x1 is 4, and since we labeled this x1, we have to label this one y1. So we can't label this y2, or else that will cause an error with our formula. Whereas x2, we can call that 2, and that means y2 has to be 2 as well. So now that we've labeled these, we can plug them into our formula here. So the distance between these points, it's the square root of x2 minus x1 squared. Well, we called x2, that is just 2. And x1 is 4. And we're subtracting, so we are subtracting 4 here. And then we have to square that. And then we have y2 minus y1. Well, y2 is 2. And we're taking away y1, which is 7, and we'll square that. So now we just simplify everything. And notice this process keeps us from having to draw a picture and create a right triangle and use the Pythagorean theorem. This essentially does all that for us. So that's the advantage of using a formula, is that it skips a lot of the prerequisite work. So 2 minus 4, that is negative 2, and we'll square that. 2 minus 7, that's negative 5, which we'll square. And remember, when we're squaring a negative number, that we're multiplying it by itself twice. So negative times negative, that becomes a positive number. So likewise, minus 5 squared is minus 5 times minus 5, which is positive 25. So rewriting this formula now, we have that our distance is the square root. This is 4, and this is 25. So 4 plus 25, that's 29. So the square root of 29, though, this is an irrational number. Since notice that you can fit the square root of 29 between root 25 and root 36. Whereas the square root of 25, that's 5, and the square root of 36 is 6. So it's between these two numbers, and since it's not a whole number, we know this is an irrational number. And this can't be simplified further, so this is actually our final answer. So the distance between these 2 points is the square root of 29, which is 5 point something. And if you want the exact value, of course, you can just plug this into your calculator. Since if you do that, the square root of 29 is 5.385, and the decimal is going to go on forever since it's an irrational number. Though remember, your calculator rounds it, so it does cut it off at some point. Even though it doesn't look like it will go on forever, it actually does since it's irrational. So remember, the main idea of this formula is that it saves you the time of having to draw out a picture of this. But that is also one way that we can check our work. So let me quickly draw a coordinate plane, and I can plot these 2 points. So this point 4, 7, we go right 4 and then up to a y value of 7. And this other point, 2 comma 2, we go over 2 and up 2. And we're finding the distance between them. So if we draw a line between the 2 points, that is essentially what we're going to find, or what we did find. And we found this was the square root of 29. It was just a little bit bigger than 5. But if we wanted to follow this out without using the distance formula, we would have to draw in a right triangle. Since remember, when deriving this formula, that's essentially what we did with 2 very general points. But drawing out this right triangle, we would drop a line straight down, but stop at the bottom of this point, and then draw a line straight over and stop at the furthest right x value. And at this point, we just need to figure out the lengths of these sides. So notice this is an x value of 2, and this is 4. So this side length is 2 units long. This is at a y value of 2, and we go all the way up to 7. So if you count, this is 5 units long. And at this point, you would use that Pythagorean theorem. A squared plus b squared is c squared, where the 2 legs of this right triangle, this is a and b. It doesn't matter which is which. So you could plug those in, and you'd get 5 squared plus 2 squared. And c, that's the hypotenuse, that's the long side. That has to be d. And notice you end up with a very similar equation. A lot of the same numbers, since you get 25 here, you get 4 here, and then to solve for d, we take a square root of both sides. So 25 and 4, that's 29. So we get the exact same number, but this distance formula, like I mentioned, this just saves us from having to draw this out and then use the Pythagorean theorem every time. With the distance formula, we can just match up what x1, x2, y1, and y2 are, and then just plug them in and simplify the formula.